Now you consider the case of 1,3-butadiene, how to arrive at the conclusion on the basis of PMO. So in all the cases in PMO method, we are always taking the lowest energy orbital, that is the lowest bonding level. So psi 1 we have taken. So here we can see that psi 1 I have taken for the butadiene. So first thing is we have to identify the orbital which is having the lowest energy. Then the orbitals which are interacting during the ring closure, that we have to identify and connect them together. So what I have done, I have taken the psi 1 and these are the p orbitals that are going to react here, that is they will be going undergoing transformation. Then I have to connect them. You can see the dotted lines connecting them. I have left here because here which lobe will be interacting is depending upon whether it is a dis process or a con process. If it is dis process, then this lobe and this lobe will be interacting with each other. If it is a con process, then this lobe will interact with this lobe. So I haven't done that. So till now I haven't decided whether it's a dis process or a con process. So simply I have connected the lobes here. Now if you are considering the con process, then this orbital will be rotating this side, the clockwise direction, and this orbital is also going to rotate in the same direction, that is the clockwise direction. So both of them will be rotating in clockwise direction. Let us assume like that. Then what will happen is, already these orbitals are interacting like this, and what about these two orbitals, how they will be interacting? So this one will be rotating downwards right side, and here with that this lobe will come and it will be interacting. So here you can see that this orbital is a shaded lobe and this orbital is having the unshaded lobe which is interacting here. So what here you can see all of them are unshaded lobe, there is no node. So all of them will be forming favoring bonding, whereas here you can see that a shaded lobe is interacting with unshaded lobe, which means that there is one node, one phase dislocation is there. So this is how many pi electrons are there? It is a 4n system. Butadiene is having 4 pi electrons, so invariably it is a 4n system. So if it is a 4n system and having one node, odd number of node, then it is Mobius aromatic. So already we know that all the ground state reaction or the thermal reaction, symmetry allowed reactions are taking place through the aromatic transition state. If it is a 4n system, it should take place through the Mobius aromatic transition state. So here you can see that the 4n system, one node formation is there, so it is Mobius aromatic, it is a thermal reaction. This is what the conclusion we have already got from the correlation diagram method and also from the frontier molecular orbital method. So what are the things we have to do? Again I am telling. So first identify the orbital which is having the lowest energy. In the case of butadiene it is psi 1. Identify the orbitals which are interacting. Connect the reacting orbitals. Then choose the method of ring closure, whether it is con rotation or dis rotation. Then rotate the orbitals accordingly. Find out how many nodes are forming. That is, like lobes are interacting means there is no node formation. If unlike nodes are, that is unlike orbitals or lobes are overlapping, there is node formation. Then on the basis of number of pi electrons present and number of nodes formed, you can identify whether it is aromatic or anti-aromatic. If the transition state is aromatic, in this case it is Mobius aromatic because 4n pi electrons and one node is formed, odd number of nodes are formed. So it is Mobius aromatic, which means that it is a thermal reaction or a symmetry allowed reaction. When you are going for the disrotatory process, what happens? These orbitals are overlapping. When this rotation is taking place, this is rotating this side and this orbital is considered to be rotating in the left hand side, that is counterclockwise direction. This orbital is considered to be rotated in the clockwise direction. You can see that all of them are shaded lobes, which means that there is no node. When 4n system is not having any node, it means that it is Mobius anti-aromatic. So it should be photochemically allowed reaction. It's a photochemical reaction. It's very simple. Similarly, you can find the result for the 4n+2 system, that is 135 hexatriene. So you have taken the psi1, connect the orbitals. I have connected all the orbitals. Whether it is taking place that is a con rotation or a dis rotation, that we have to decide. So when you are considering the con rotation, you can see that all these orbitals are already connected. Now we will be connecting this and this. So we have to connect these two. You can see that how many pi electrons are there? 4n+2 pi electrons. 6 pi electrons are there, which means that it is a 4n+2 system, and there is node formation. If it is a 4n+2 system, there should not be node, because a Huckel aromaticity. For a Huckel aromaticity, the 4n+2 system is falling under the category of Huckel aromaticity. It should not have any node, but here there is node formation, which means that it is Huckel anti-aromatic. So it cannot be thermal reaction. So it is photochemically allowed. Whereas when you are considering the disrotatory process, you can see that both of them are rotating in the opposite direction. All the shaded lobes are interacting. So it is a 4n+2 system with 0 nodes. It's Huckel aromatic. So it's a thermally allowed process. So it's very simple to arrive at conclusion by taking either frontier molecular orbital method or the perturbational molecular orbital method. In fact, only for electrocyclic reactions we are using the correlation diagram method. For other type of pericyclic reactions, we are using either frontier molecular orbital method or probably the perturbational molecular orbital method to arrive the conclusion very easily. So we will continue with the cycloaddition reactions in the next video. But here in the end, I have given some of the practice problems. You can try to work it out and find out. If you are having any doubt, please message me in the classroom. I will answer. Thank you.